Anyone else miss the notes? All right, so we've talked about circles for a couple of lessons. Remember that a circle is just a set of points equidistant from a given point. We call that distance from the given point to all of the points on the circle. We call that distance the radius, and we call that point the center. Now, how interesting that I used the word distance, that the distance is always the same. So, once again, that distance is the radius of the circle. The given point is the center. And we can use the distance formula to come up with an equation for a circle in the coordinate plane. Now, on the reference sheet is a whole heck of a lot of what's going on in this chapter. This formula for the equation of a circle is not. However, since it comes from the distance formula, if for whatever reason it falls out of your brain, try to remember how we came up with the equation of a circle. So here it is. That distance, we're not going to label as d, we're going to label it as r. Okay, so the radius is the distance between any point on the circle. We'll call those the x and y. And the center of the circle, which we will call HK. Bless you. Become, by the way, very familiar with H, K. You'll see H, K a lot next year when you get into Algebra 2 and you start graphing all kinds of other things. H, K is usually referred to as our focal point, our important point. If it's a parabola, it's the vertex. If it's the circle, it's the center. Things like that. H, K, you'll see it a lot. So, x minus h plus y minus k is what you're looking at in that distance formula. But the standard form of the equation doesn't like this square root sign in it, so we're just going to square both sides of the equation. So what we end up with is r squared equals x minus h quantity squared plus y minus k quantity squared. And that standard form of the equation basically sums up everything that we're talking about today. So, starting very simply, taking a point and a radius and plugging it into that standard form of the equation of a circle. Now, granted, this isn't as pretty, perhaps, as y equals mx plus b, but you were able to, last year, without any difficulty, take the m and take the b when they were given to you and plug them into the equation of a line. This is the same idea. Okay? So, our equation becomes x minus negative 6 squared plus y minus 8 squared equals my radius squared. And then, if it's possible to clean it up, of course, you're expected to clean it up. What can I clean up here? What can I clean up here? The 5 squared, what else? Right, let's change this to x plus 6. So the answer I would want would be x plus 6 squared plus y minus 8 squared equals 25. And that's the first step of that learning process in this lesson, is being able to take the information and put it into the equation. Eventually, you'll be expected to look at the equation and pull the information out of it. So let me point something out to you now. Look at how the x-coordinate of the center is negative and how the y-coordinate is positive. Look at it in the equation. Do you see that the signs in the equation are the opposite of the signs of the point. Keep that in mind when we get to problem 2. In the meantime, though, there's a your turn. Please work through that. From what I'm seeing, you're ready to compare your answers to mine. Please check your answers against what I have on the screen. And if something is off, let's make sure that we're talking about it. Pretty straightforward. Right, remember that the square root of 2 squared would be square root of 4, which is just 2. All right, in problem 2, I'm asked for the equation of the circle with, I'm given the center, but this time I'm not given the radius. I'm given a point on the circle. Where would I go from here? Zoe. Find the length of the radius. Absolutely. Using what? The distance formula. Fantastic. So my radius will equal the distance between those 2 points. 4 minus 2 squared plus, 2 minus -3 squared. And that's the square root of 2 squared, which is 4, plus 5 squared, which is 25, leaving me with the square root of 29. Why is there no reason for me to either try simplifying that radical, in this case it doesn't, or evaluate that radical and figure out what the square root of 29 is? Why is there no reason I should do that? Why is that a waste of time? Because I'm going to be squaring it anyway in order to write the equation of the circle. Fantastic. Can one person please give me the equation of the circle? What will the equation of the circle be? Adrian. Question, please. Let's backtrack. You understand why I plugged these points in here? Okay. 4 minus 2 is 2. 2 squared is 4. 2 plus 3 is 5. 5 squared is 25. 4 plus 25. All right, it's Monday for me too. Yes, ma'am. You have the equation. I love it. X minus 4 squared. Good. Plus y minus 2 squared. Remember, you're just squaring this, so it becomes 29. Good on the screen. And I believe there's a your turn just like it. Lovely. Take a moment and work through that, please. Based on what I'm seeing and hearing, you're ready to compare your answer for the your turn problem 2 with mine. If there's a question, concern, I was asked an excellent question. If one person was thinking it, chances are someone else was also. Does it matter which point you use, whether you're using this 4, 3 or this -1, yes, it does make a difference. And I can understand where that question may come from. Last year in Algebra 1, it didn't matter which point of the line you were plugging into the equation. You ended up in the same place at the end. Be careful, however, that the 4, 3 is not a point on the circle. The -1, 1 is. This stuff on the outside. Remember that the equation of the circle is based on that point in the middle, the center. You must use the 4, 3. Okay, any questions up here? Right. Last kind of problem that you could encounter. In problem 3, what is the center and radius of this circle, and graph it so. Remember what I called to your attention in problem 1. What is the center of this circle? Helena. Beautiful. The center of this circle is 3, -2. What is the radius of this circle? Someone else, please don't call it out. What is the radius of the circle, Sarah? It's 6. Okay, nobody's expecting a masterpiece work of art. You plot the center at 3, -2. You count 6 spaces in your 4 basic directions. And you connect the dots. Badly drawn, but you get the idea. Finally, there's a your turn, just like this one. And I can't even look at that clock. And we do have a daily quiz thereafter. I have not yet activated it. Please do the your turn first. And your graph should resemble mine, having a center of 2, 3 and a radius of 10. Okay. I will be activating a daily quiz on Socrative and putting the book on the screen if you want to get a jump on the assignment.